Hello YouTube, welcome back to my channel. Well, if you're new to this channel, my name is Prince. So in this tutorial, we're going to look at data visualization in Python using the Python Seaborn library. So this is just a simple introduction to Seaborn crash course that introduces you to Seaborn. So this course is for anyone that wants to learn data visualization in Python, or anyone who is about to do data analysis in Python, machine learning, data science, and stuff like that. This tutorial is for you. So it is going to introduce you to how to visualize data in Python. So let me just go ahead and show you some of the things that you'll be able to do at the end of this tutorial. So at the end of this tutorial, you're supposed to be you'll be able to draw graphs, different graphs like the ones that you have drawn here. So I'll just scroll down to show you some of the graphs that you'll be able to draw once we are done with this specific tutorial. Okay, so you'll be able to draw all different graphs like this, and there's so much more. Okay, so now one of the prerequisites that you need to have to follow along with this tutorial is that you need to have the Python you need to have Python installed on your laptop, and then you also need to have the Seaborn library and the matplot library installed also on your machine. So if you know how to import to install this on your machine, I already have a tutorial on how to install these libraries, including Jupyter Notebook, Seaborn, matplotlib, and so on. So you can just refer that tutorial on my channel. So now that I assume that you have that installed, let's get started by importing the necessary library. So first of all, we just import the Seaborn as we import the Seaborn as an SNS. Okay, that's just a common alias name. So also import just say from matplotlib. So matplotlib is just something that so Seaborn is built on top of matplotlib, so also be using matplotlib in this section. So for matplotlib import, we're going to import the pyplot as so this is as plt. So this is a common way, that's a common convention. So we're going to import matplotlib. From matplotlib, we're going to import the pyplot as plt, and also going to import Seaborn as a SNS. So now that you have done that, let's go ahead and actually see some of the data sets that the Seaborn comes in built with. So whenever you start data visualization, one of the biggest challenges is actually getting a clean data set that you can work with. So Seaborn provides us with some of the common data set that you can use to visualize data and to practice that. So you don't have to start searching for CSV files or any kind of data set in order to work in order to do data visualization using Seaborn. So let me just go ahead and show you some of the pre-built-in data sets that come with Seaborn. So it is a Seaborn .get. This is dataset underscore names. So this will just return to you the dataset names. So just wait for this to run. So this will just return for you some of the common data sets that Seaborn comes. So you can see all of these are just data sets. So in our case, you're going to be using the Penguin dataset and the tips dataset for this tutorial. So let me first begin by using the Penguin dataset. So let's go ahead and actually import it. So to import it, just call it Penguin. I'll call it Penguin. So I'll just call it Penguins equals to now I'll go ahead and actually import sns.load underscore dataset. So we load dataset and then provide the name of this dataset. So I'll simply just come this way and I'll copy that value and I'll paste it in here. So I'll just run the code, and I'll first print Penguin so that we can see what we have there. So this is the Penguin dataset. You can see we have all of this data without having actually to do anything to get this data. Just by installing Seaborn, we can have access to this data. So this is really, really great. So now that you have done that, let's go ahead and actually try to start drawing our graph. So the first graph we're going to draw is about a relational graph. So whenever you have data and you want to see the relationship between this data, you can use the rel plot, which is just for relation for drawing relationship graphs. Okay, so just say sns.rel plot, rel plot, and then in here we can provide the x-axis. So x-axis, we're just going to provide any column from here. So we provide any file column from here. So I'm going to use this specific column. So I'll simply just copy it and then I'll paste it down here. Paste it, and then I'm going to now specify the y-axis. So the y-axis is just going to be the build length, the build depth, okay, in millimeters. So just go up here and type it build underscore depth underscore millimeters, and then we can just go and specify we can just go ahead and actually specify the data frame that this data set comes from. So you specify the data set, which is Penguin, right? We call it Penguin penguins. Okay, so run this, and then this will draw for us the graph, and you can see we have that graph right over here. So we can actually go ahead and actually customize this graph. For example, we can specify the hue and so on. So you can just go specify the hue, which is just be what you want to draw it around the graph on. So you specify the species, and the species is also a column from this graph over here, species. Okay, so I'll just run that and draw the graph around the species, and you can see we have this clearly well labeled. So I'll just zoom out a bit. I hope you can still see. So yeah, we have that right there. So I'll also go ahead and actually do you can specify the size. The size can be based on another categorical value column. So this will just be the length. So just say length underscore millimeters, and then this is underscore, and then millimeters, the small capital M. And you can also specify the style. So this is running off the page, so I'll just come down here and specify the style, as the style can also be a species. Okay, so we can specify the style as species, and we can run that graph, and you can see we have this really great looking graph right here. So that's how you can draw a relationship graph in Seaborn. So now let's move on to how to drawing joint plots in Seaborn. So to draw a joint plot, just SNS dot joint plot, and then you specify the value. So you specify the x-axis, and then I'll also go ahead and actually use build underscore length, and then this is in then underscore millimeters, and then we can also go ahead and specify the y plot. The y plot, I'm just going to use this column here. Let me just scroll up and show you. I'll be using this column right here. So it's flipper length underscore millimeters. So flipper underscore length. For some reason I'm always getting the spelling of the length wrong today. So flipper underscore length, and then we can go ahead and specify the data. So the data is just going to be a penguin, the data frame that you use, penguins. You go to penguins, and then we can go ahead and actually draw that graph just like this, and you can see we have that joint plot right here. So you can go ahead and actually customize this graph further. So you can specify the hue again. I know we won't specify the hue this time. You can go ahead and specify the kind. So in the kind, we can just specify different kinds. Okay, you can just go ahead and specify red. You can draw a regression line through the points there. You can see we have that regression line through this scattered plot. We can also go ahead and also do a KDE plot, kernel density estimator. This will just draw for us this specific graph, and then we can also specify the hex. Now the hex is one of my favorites because it's easier to interpret. So the areas that are having the dark they are much darker, have higher concentrations. Okay, so that's very easy to interpret. That's why the hex is actually my favorite. So let's go ahead and actually go to another type of graph. We're just going to call this the regression graph. Okay, so to draw a regression graph is SNS, and then go LM plot, and then you can go ahead and actually specify the x-axis. So I'll specify the x-axis as body mass. So body mass is just another column from our data set, and then we will actually specify the y-axis. So the y-axis is going to be the flipper length. We have already looked at it. So the flipper length underscore millimeters, and then we can go ahead and actually specify the let's just draw it for now, then later we can specify customize it. So if you draw this graph, I got an error. So let's go up here and see where the error is. I didn't specify the data type. Okay, so let's go ahead and specify the data, which is the penguins, right? Call it penguins. So run this, and you should get that regression plots right there. So you can see that the body mass on the x-axis and the flipper size have a linear relationship. So as the body mass increases, also the flipper length increases, right? That makes complete sense. So let's customize this by specifying the hue, and the hue just specified around the species, right? So species, and then we can draw that graph right there. So we can have this specific nice looking graph to show the relationship between different species, right? So now you can go ahead and actually draw another kind of graph, which is just the dist plot, right? So dist plot is used to draw a distribution graphs. So we can just specify the x-axis here and the data type. So just say x. You can specify the x-axis and to draw the distribution of that. So we're going to use the body mass. So we want to see how the body mass is distributed. So how the body mass is distributed, and we can specify now the data type, which is the data set, which is penguin. We call it penguins, right? So you can just dist it's called the dist plot, right? Sorry, is this plot is SNS dot, okay, I forgot that. So SNS, you can see we have that beautiful dist plot right there. So you can actually go ahead and customize this further by specifying the kind and stuff like that. So you can specify the kind and you can specify different kinds. So we can go ahead and specify the hist. So that by default this is a histogram, right? So hist, if you specify hist here, you just get the same graph back, which is just a histogram. So you can specify other kinds. You can specify kernel density estimator, and then you get that this beautiful line to show the distribution, right? So you can also go ahead and specify the another kind, which is the ECDF, right? I think it's the ECDF. Run that, and then you can have this graph good looking graph right there. So you can go ahead and actually go to one more data, another kind of graph that you can draw. So you can just go and use the SNS.pairplot. So pairplot is commonly used, very commonly used. So pairplot is just going to draw for you all possible combination. So you just have to specify the data and then to draw for you all the graphs that can come with this. So this will just take some time. You need to run, and we can have that we can see we have a lot of graphs, right? Just by using the pairplot and providing the data type, the data frame, and you can see we have all of these beautiful looking graphs. Okay, so now we can go ahead and actually customize this more. You can specify the hue. You can specify the hue to be maybe the sex. So the sex is just a column that comes within our data frame. So you can specify the sex, and you can draw that pairplots around the sex. Okay, so just wait for this to load. And you can also draw it around. You can see we have that beautiful looking graph, and the blue is a male, and then the other color is for the female sex. Okay, so you can actually go ahead and specify the species. So this is just a categorical column, so species, and then you can also draw it around the species. This will return to us the same pairplot, but drawing it around the species instead. So let's wait for that to load, and you can see we have the different species. We have the atelier, which is in blue, and then the gentle, which is in green, and so on like that. So you can see how easy it is to draw graphs just by using the pairplots, right? So now let's move on to another kind of graph that you can draw in Seaborn. This is just known as the bar plot. So now this section that we're going into, we're going to be going into the section of plotting categorical values. Okay, so we're going to go into the portion of drawing categorical plots. So I'll just make that known here. So I'll just say categorical plots, right? Plots. So now you can draw those categorical plots. So the first thing that we'll be looking at is the bar categorical plot. But for now, let's change the data type. So I'll just use another data type, data set, which I call it tips. So I'll just go sns.load. We have seen this earlier, load data set, and then we provide the name of the data set. So this data set is simply called penguin. So just go ahead and specify in here. It's called tip. So just run this, and if I didn't make any mistake, then that's the data set. So this will take some time. I think it's tips, right? Yeah. So just run this, and we should get back the data. So now I can just go ahead and type in here tips, and then this is tips, and then we can run this, and you can see we have that data frame right there. So now let's go ahead and actually draw a bar plot. So we're going to say sns.bar plot, and then in here you're just going to specify the x-axis. I'll go for 6. Okay, so I'll just go to the x-axis is 6, and then we can go ahead and specify the y-axis. And the y-axis I'm going to use tip, and then we can go ahead and specify the data set from which all these columns are coming from, Jesus. And then we can see we have that data, that bar plot right there. So you can go ahead and actually specify the estimator. So the estimator is a value that is used to calculate the length of this, the height of these boxes, right? So we can go ahead and actually specify the estimator. The estimator can be numpy.mean. So this will just allow us to use the mean. Okay, so now we need to import numpy. So we'll just scroll up here, and we'll import numpy as well. Okay, so if you didn't install numpy, you can just go pip install numpy. Okay, so import numpy as np. So run this. This will import for us numpy. So come back here, down here, and then this will draw the value around. So I think it's just this is not just like this. So you can have the value, the height of this length of these boxes be calculated according to the mean, and we can also go to STD, which will be the standard deviation, and we can also draw one against the variance. So you can just draw the VAR and the variance. Okay, so now the order of the so if you want to draw what I mean by this, I'll just show you. It's much easier to show than to explain. So let's draw this. You can see now we have the labels on the y-axis, and then on the actual values on the on the x-axis, right? So we can see how we can draw this graph in different orientations. Okay, so now let's go ahead and actually see another kind of categorical plots that you can draw. So this is just going to be a count plot. So this is a count plot. So we specify in a value, and then need to return to you the count of that specific plot. So we just go x, and then we can just specify the count. We want the count of all the days, right? So let's say days. I think it's called day in the data set, and specify the data frame is coming from is tips, right? So you can just draw that, and you can see the count of these days. So we have the most days being Saturday, and then the second being the Sundays, and then the least being the Fridays, right? So you can just change this into different things. Okay, so you can also say this as a smoker. So this smokers is also coming from our data set. I think it's called smoker, right? If I'm not mistaken, yeah, smoker. So you can see the count of smoker. So you can see the number of people who don't smoke is more than the number of people who actually smoke. And you can also change this to time and so on. So you can just say time, and you run this, you can get different times. You can see that most tips are given around the dinner time, okay, not the lunch time. So yeah, that's one of the another kind of categorical plots that you can draw. So now let's look at another plot, which says the KDE plot. So I told KDE stands for kernel density estimator. So to draw a KDE plot, this says KDE plot, and then in here you need to specify the values that you want to drag in. So you just go say total underscore bill. So total bill is just another data set that is another column from our data set. We need to provide now the data set, which is the tips. Okay, so run this code, and we can see we have that data set right there. Okay, you can see you have that data set right there, and it's showing the distribution of that. So this is density and distribution. So you can see that most is around 15, right? Around 15 to 20, where the density is the highest. Okay, so now let's go on to drawing a box plot. So xns.box plot, and then just say box plot, and here you need to specify the x-axis. So x-axis you can specify the tips, although this is actually a string, so tips, and then you can specify now the data set from which this column is coming from. So tips like this, and then we can just go ahead. I got this is actually tip. I don't know why I'm keep on adding ss to it. So this is the tip. Now you can see this exact of a box plot. So now if you don't know what a box plot is, this is actually very easy to interpret. So this is the mean value, this is the max value, which is not, this is the mean value which is not an outlier, this is the max value which is not an outlier. So this line I called whiskers, right? So this is the line in the middle of the box is the median of the data set of the data, right? So and then this one is the first quantile, this is the second quantile, this is the third quantile. Okay, so those are known as the outliers. So that's how you can interpret box plot. So you can draw box plot by specifying also the x and the y axis. So let's go and specify the y axis. So the y axis could just be the days, and then we can draw that graph, right? You can just draw like this. So I specified, I forgot a comma here, so run that. Actually it's day, right? I don't know why I keep making this error, but it's day, and you can see that we have that box plot right there. So you can also go ahead and actually customize this further by specifying the hue and stuff like that. So you can just come in and specify the hue, and then the hue could just be 6 or something like that. So you can see the around the 6, and then you can also specify you can specify around the time, and the categorical value is specified around the time. So these are outliers, right? So you can see that those are outliers. So this is the maximum value that is not an outlier, this is the minimum but is not an outlier. The line in the middle is the median. This is the first quantile, the second quantile, and the third quantile values. Okay, so now let's move on to another graph, and this we're going to talk about the cat plot, right? So the cat stands for categorical plot. So let's say next.cat plot. Okay, so cat plot, and then in here we can specify the x-axis. So the x to just be, you can specify in this to be the day, and then we can go ahead and specify the y-axis. The y-axis could just be tips. Okay, tip. Okay, so and then we can go ahead and actually specify the data frame from which this is coming from, these columns are coming from. So we got the tips, so you can go ahead and actually plot that graph, and you can see we have that cat plot right there. So we can actually go and specify do more customizations to this. So you can specify the hue, and then specify the hue as being the sex, and then run this. You can get the hue, you can get the male and the female, okay, being separately identified. And then you can also specify the dodge to be true. So the dodge to be true, it will just separate the male and the female value, so we can get that the males on one side and the females on their own side, not being mixed like previously. So that's what the dodge does. So you can also change this, you can draw it around the time and stuff like that. So yeah, that's all I want. Let's talk about in this type of graph. So let's move on to another type of graph, which we're just going to go on to how to customize our graph, right? So let's use this graph to learn how to customize our graph. So we can just go and actually specify the custom theme in Seaborn. So to do a custom theme is sns.set underscore theme. So this will just use the custom theme in Seaborn. So go ahead and run this, we should get the same output. You can see we have now a different custom theme in Seaborn. So you can just go ahead and set sns.set context. So the context allows us to control how the graph can be displayed. So in here you can provide 4 values, right? So you can say that this is a poster, depending on if you're making this graph for a poster, this is how it will look like. If you're making it for talk, maybe you're trying to explain something to someone, you need to maybe talk, and then you can see how it will look like, and then you can go to notebook and how it will look like in a notebook. So you can just say note book, and then you can run that and you see how it looks like in a notebook, and so on. So there's the 4th one is just paper poster, and we didn't talk about paper. So paper, maybe you want to print it, so just run this and you see how the graph will look like on paper. Okay, so now there's no much visual difference because I have actually zoomed it. I think it affected the quality of the drawings, but if you zoom out and you draw it on your own PC, you can actually notice the differences. So now let's go on to how to set the style. So you can just go up here and say sns.set, and then you can say set underscore style. So you can specify different styles. You can specify dark grid, and so on like that. So we can have a dark grid, and you can also specify a white grid, and then you can run that. You can have a white grid right there. So you can also control the style of our plot. So now that you have done that, let's actually go ahead and actually draw see how we can draw the confusion matrix. So this is our last plot for this tutorial. So let's go ahead and see how we can draw our heat map. Okay, so to first do that, we need actually to have a correlation matrix. So I'm just going to say tips.corr, and then this will return to us the correlation matrix. So I'll just print it here so that you guys can see. So I'll just run that specific cell, and here we have the correlation matrix. So to draw a heat map in Seaborn, this sns.heat map, and then we can go ahead and very specify the correlation matrix, and then you can also just run this for now so that you guys can see. Now we have that matrix confusion, the heat map right there. So you can actually go ahead and actually do a note. You can see right now there are no values inside of this individual cell, so you can just say a note equals true. So a note equals to true. This will allow us to actually see the numbers that are actually supposed to be there. So you can see that the correlation between these different variables. Okay, you can see that the correlation between total bill and bill itself is 1, because total bill cannot have better relationship compared to any other column other than itself. That's why it's 1, right? And then you can see other correlations between different columns. Okay, so in case you want to see the correlation between graphs, you can do that. So now you can see our graph is really small. So how can we make this big? So to make this big, you just use matplotlib. That's why I imported it. So matplotlib.figure. This you can create a figure, and you can specify the figure size. So the figure size, this will just be a tuple specifying the length, the height and the width. Okay, so I'll go 12:7. So this should just bring us this bigger graph, as you can see over here. So now let's actually go and see if we can customize this further. So we can go ahead and actually say we can specify the title of this graph. So let me just say my title, and then you can run this. You can see that title has no attribute title. Okay, this is a matplotlib, so this is plt.title, and then we can see we have that title right there, my title right there. And you also can specify plt. We can go ahead and specify the x label and the y labels specifically. So the x label, I'll just call it x label. So you can just go ahead and you see that x label right here down here, and you also specify the y label. So just move down here, plt.y label, and then you can specify the y label of this graph. So you can just run that, and you can have the y label right here. So now that you have done that, you can also specify the color maps to the graph. So just say cmap, and then you can just specify the cmap. So you can just there are different cmaps that you can use. For example, you can use accent, and then you can run that. You can see you have different color map, and you can also use accent underscore r. You can use that. You can also use one called rainbow. So rainbow, just like this, and you can have one rainbow, very colorful, right? Rainbow underscore r is also one of them. Okay, so now they have different color maps. You can just go online and search for Seaborn color maps, and then you can see actually a lot of those color maps. So if you want to do that, what I usually do, I just type in some gibberish, and then I run the code. I'll get an error, and I can see all the different color maps right here. So you can see one called winter. So just copy that and scroll up here and paste it instead of this gibberish. I'll replace the gibberish with that, so you can have that right there. So if you don't know the color maps, you can type in this gibberish, and then you can just get an error. From the error, you can get different color maps that you can use. Okay, so let me just show you one more last thing about the labels position. So for example, up here we can just say plt we can say legend. Okay, the legend, and you can specify the location. So you can specify an integer between 0 and 4. Okay, so 0 being the default where this label is placed, and then you can specify different values, and that to change the position of that legend. Okay, I made a mistake here, so this is actually legend right there. So run this again, and you can see I have our legend now moved here. So if I change this to 6, our legend should be somewhere around here. So I run this, you can see our legend is there. So this is how you can move the legend around using the different numbers. So you can move the legend around. You can just experiment to find where you want to put that legend. So guys, this is all I wanted to talk to you about in this tutorial. I hope this tutorial was really helpful for you and gave you a solid foundation to build on in case you want to master data visualization using Seaborn. So if you find this tutorial helpful, please I kindly ask you to subscribe to this channel and like this video, and also drop a comment or any feedback in the comment section below. So in the next tutorial, we'll actually be looking at how to use pandas in Python, introduction to pandas library, right? So pandas is used for like visualizing, not really visualizing, but like giving you like an Excel kind of feature by using Python. Okay, so that's what we'll be looking at in the next tutorial. So thanks for watching. If you haven't subscribed to this channel, I kindly ask you to subscribe to this channel and like this video. So see you in the next tutorial. Keep safe.